Malcolm Training Tutorials, Configuration, Ingesting Traffic, Capturing Live Network Traffic for Analysis. In this video, you will learn how to capture live network traffic using a Malcolm instance without an external dedicated network sensor. We will cover 3 topics. 1. Simple configuration. 2. Advanced configurations and filters. And 3. Viewing the captured data and statistics. As opposed to using a dedicated network sensor device running Hedgehog Linux, a single Malcolm instance can capture live network traffic data on one or more network interfaces. While this might seem simpler than using distributed sensors, the choice depends on the complexity of the network and needs of the user configuring the capture.
Topic 1. Simple configuration. There are 3 ways to get network data into Malcolm. 1. Using a dedicated device running Hedgehog Linux to capture traffic and send its metadata to Malcolm. 2. Uploading a previously captured PCAP file into Malcolm. 3. Configuring Malcolm to capture live traffic directly. Today, we will focus solely on the third method, configuring Malcolm to monitor one or more local network interfaces for network traffic analysis. For more complex setups requiring multiple capture points, please watch Configuring Hedgehog Linux. Simple configuration is used when you don't need any custom settings or capture filters, and you prefer to use the default options. We will cover custom options later in the video. To accept the default network traffic capture options, proceed through the beginning of the Malcolm configuration as covered in the Configuring Malcolm video. Then, when asked, should Malcolm capture live network traffic? Select Yes. Click OK. Then specify the names of the network interface on which Malcolm should capture traffic. To listen on multiple network interfaces, separate the interface names with a comma. Malcolm instances can have more than 2 network interfaces. The names and roles of the network interfaces on your Malcolm system will vary. For this demo, we are using a virtual machine with only one interface, named ENP1S0. Once you have defined your capture interfaces, click OK. And now the simple configuration for network traffic capture is complete.
Topic 2. Advanced configuration and filters. For a more advanced network traffic capture setup, you will want to follow the custom configuration. Customizing allows for more flexibility and control for power users. When prompted with, should Malcolm capture live network traffic? Select Customize, then click OK. Malcolm has 3 primary tools used for capturing network traffic and generating metadata about that traffic. They are ArcMe, Zeek, and Suricata. We will now proceed to configure capture for these tools. You will be asked whether Malcolm should capture live network traffic to PCAP files for analysis with ArcMe. Select Yes. Malcolm can use either NetSniff-NG or TCP-dump to buffer captured traffic. For processing by ArcMe, we recommend selecting NetSniff-NG, so select Yes when prompted to do so. Next, when asked if Malcolm should analyze live network traffic with Suricata, select Yes. Finally, when asked about analyzing traffic with Zeek, select Yes. Up until this point in the custom configuration, we have enabled traffic capture for all 3 of the tools Malcolm uses for this purpose. This is equivalent to having selected Yes instead of Customize, as illustrated earlier in this video. One reason to select Provide Custom Capture Settings is to define capture filters to limit the volume of the network traffic written to disk for analysis. If your network has a noisy protocol that's not useful to save, something like the live video feed from security cameras, this traffic can be filtered out to conserve storage space and reduce processing load. For example, if you wanted to filter out real-time streaming protocol (RTSP) video data, you could look up the port it uses, which in this case is port 554. Then, set the filter to not port 554 to exclude that data from being captured. Capture filters are specified using standard Berkeley packet filter syntax, which is also used by other common tools like Wireshark and TCP-dump. Modern network interfaces have many optimizations enabled by default, which can interfere with getting an accurate capture of network traffic. When asked, disable capture interface hardware offloading and adjust ring buffer sizes. Answer yes to ensure the capture interfaces are properly set up to capture an accurate copy of all network traffic they observe. This next part is optional but useful. It enables live packet capture statistics for Zeek and Suricata, collecting details like how much data has been captured, capture speed, and any errors or dropping packets. To enable the gathering of these statistics, select Yes.
Next, let's explore the results of our capture. Navigate to the Malcolm landing page. Click on Dashboards. The Overview dashboard will open. Note that by default, this shows the last 15 minutes of live traffic. We can confirm traffic capture is working by noting the presence of the Zeek and Suricata logs, summarized here on the Overview dashboard. At the top of the Overview dashboard, you'll find the log source visualization. This table shows all the traffic capture sources and the last time data was received from each of them. In this demo, we only have the single Malcolm instance. If there were multiple data sources, such as other devices running Hedgehog Linux, they would also appear here. You can see the instance name and the last time it ingested a record, at 1705. It also shows the total number of records. Because traffic collection is happening in real time, refreshing the dashboard causes the data display to update. Notice, the last log in time updates to 1706, and the record count increases. As long as live traffic is observed across Malcolm's capture interfaces, each refresh of the dashboard will update with the latest network logs. Earlier, we enabled the option to gather traffic capture statistics. The Packet Capture Statistics dashboard allows us to visualize these statistics. To view them, scroll down in the navigation menu, find and click on the Packet Capture Statistics dashboard. You can now see more detailed information about the captured traffic. As opposed to the log source visualization discussed earlier, this dashboard is further broken down by event provider, Zeek versus Suricata, in addition to the capture host. You can also see an overview of the packet and data volume captured over the dashboard search timeframe. For example, here both Zeek and Suricata report having observed about 1.5 petabytes of network traffic in the last 30 minutes. Don't be alarmed if the traffic volume numbers differ slightly between Zeek and Suricata. These variations are due to variations in how capture statistics are generated and reported. If the Packet Capture Statistics dashboard reports drop packets, it may indicate that the network traffic exceeds the capacity the Malcolm instance is able to handle, possibly due to insufficient CPU or memory resources. A small number of occasional drop packets are not a concern, but a large number suggests you should review the resources allocated to the Malcolm machine. Implement a traffic capture filter, or consider distributing the loadout to external network sensors running Hedgehog Linux instead.
This concludes Malcolm configuration, ingesting traffic, capturing live network traffic. Check out the description section for links to the Malcolm GitHub site, a Malcolm discussion forum, and more.